Swayam Prabha. Digital India. Educated India.
Hello, Namaste. Welcome back to the course on Geographic Information System. In today's class, as I said in the previous class, we will look at more of open source GIS software. So, we looked at the licensing system, now we are looking at the software. So, one or two of these softwares you may have learnt in the previous 2 weeks. I would not go into details of those softwares, but I would give you one very good software which can be used in urban as an urban analytical tool. Extremely good in terms of analyzing urban. I have used it for urban, I have used it for various other measurements in terms of urban data. So, it can be used for ecological purposes, it can be used for environmental purposes, it can be used for hydrological purpose. So, the way you think, you can modify that particular software for finding out different metrics. So, I'll speak about some of these softwares. Maybe you can use it for your own research code. So, let us look at the content. So, the first thing I would speak about an open source software image map. So, this is a kind of software which can be used and modified by any user, so that the image map or the analysis any kind of analysis can be done in a much easier way. Then you have GDAL. GDAL is one of the extremely powerful software which is powering extremely powerful library which is actually powering most of the softwares, GIS softwares that are available today. And OGR is other software which is complementing GDAL in terms of handling the vector data. So, this both are the backbone of most of the GIS softwares available today. And I would also speak about GRASS, QGIS and TrackStat. I will give you a brief introduction and a small example of how we look at the software as it is. Okay. The first software, when we look at as I said, as an open source software image map. So, you may not have heard about this, but it is extremely good software library. It is written in C++, okay, that provides an advanced remote sensing, image processing and geospatial functionaries. So, why I am trying to tell about OSSIM is that, for example, we spoke about what do you mean by remote sensing very briefly. If someone wants to combine the GIS, remote sensing and image processing together to produce some good results. So, OSSIM can be one of those software libraries which can be extremely helpful for many of you. So, it includes orthorectification, precision terrain correction, rigorous sensor models, very large mosaics. So, if you have today's computer is easy to handle can handle anything. So, that's how you can look at any of those applications that can come in. For example, a cross sensor fusions, wide range of map projections, datums and a large range of commercial and government data formats. So, all of this can be handled using OSSIM. So, if someone is trying to develop something or someone is not able to maybe look at the software functionalities, when you are looking at data management or developing an image processing tool or looking at image processing as an effective tool, so you can look at OSSIM so that your analysis becomes much faster and more productive. So, when I look at OSSIM as a planet, it is an accurate 3D global and geospatial viewer that is built on top of OSSIM. So, please look at it. OSSIM planet is very good in terms of visualization. It is a 3D global visualization. Please look at it. If you look at the way it has evolved today, OSSIM is one of those libraries that has to be looked at when you are trying to do research using image processing and its applications. So, the next thing is GDAL. So, GDAL is basically a translator library, Okay, I could say it as a translator library for raster geospatial data formats. So when I say raster geospatial data formats, it handles effectively the raster model. Okay, so it also comes with a variety of useful command line utilities for data translation processing. And when you look at this GDAL, take it any software, whether you are using ERDAS, whether using any of those raster processing, very good capable raster processing software, the raster library is formed through the GDAL translator itself. Okay, so the entire handling of the raster data is through GDAL. Okay, so when you look at OGR, OGR complements GDAL with a vector as a vector translator. Okay, OGR simple features library is an C++ open source library written in C++ and providing read access to variety of vector files formats, including whether it is shapefile, most of you use a shapefile, HTTPS, PostGIS, Oracle Spatial, MapInfo, MIDMF or a tab format. So all of these can be easily handled by OGR. So now take any vector software that is in the market today, whether it is proprietary or open source, the basic library behind all of this software is OGR. Okay, basic library behind a raster software is nothing but GDAL. So whether you are trying to buy a proprietary license, basically the thing that is the brain behind us, it is GDAL and OGR. Okay, but only thing is that in a proprietary software it is much easier for you to access all the tools easily and to most importantly it looks maybe more interesting in terms of when you look at it as a visual enterprise. But when you are looking at open source software, it may be a bit difficult that you have to get accustomed for a few days, but once you are accustomed, open source software is also as beautiful as your proprietary softwares. So what can you do basically if someone asks me with GDAL? So GDAL can do everything that is on the planet for a rastered module. So it can report information about a file, copy a raster file with control of an output format, warp an image into a new coordinate system. Okay, we have seen this how I think Mr. Chandan spoke about how a new coordinate system it can be transformed, then convert nearly black or white borders to the exact values. Okay, so this also can be handled effectively by GDAL tools. It can derive contours from DEM, tools to analyze and visualize DEMs, build a quick mosaic and rasterize vectors into a raster file, transform coordinates, anything that you ask for as far as raster data model is concerned. So all of these things can be done by GDAL. And when you look at OGR has huge number of formats that it can support, whether it is AVC bin, whether it is BNA, CSV is your comma separated value format, then you have DGN, then you have shapefile, GML, now well known language GML is being used in a lot of contexts, extremely flexible language. Then you have extension, and then you have GMT, GPX, GRASS has its own thing through OGR sources in QGIS. Then you have MySQL, SDTS, SQLite, NTF, Tiger. So all of these things can be handled very effectively through the OGR in QGIS. Okay, when you are looking at OGR targets, any of these, I mean the way it is saved, whatever it has, whatever the target you need, the well known targets, every target or every extension is possible with OGR. That is a backbone of vector data model in QGIS. So when so just to put thing in your mind, GDAL and OGR are two libraries which are actually powering. GDAL is powering a raster data model and OGR is powering a vector data model. So with combination of this, the other tools are being built, and you have a beautiful interface that has been shown to you so that you don't go into command line and use it, though that is more flexible. Okay, so this basically both of these are handling entire GIS softwares. So if you understand both of these, you don't need to buy any GIS software. Okay, so it's much easier than buying a GIS software. So GRASS GIS is one of those extremely good raster processing software, open source software available today, and GRASS GIS has evolved over a period of time, and it is the world's biggest funded open source software program on earth today. So when you look at the GRASS GIS is very effective, and most importantly GRASS GIS is a complete software, whether you are looking with working with Python or whether you are working directly as a standalone software. GRASS GIS can handle anything. Okay, so it offers an environment of WX Python wherein you can start coding by yourself, use the modules and open source that have been already been built with the GRASS GIS, and develop your own context whenever you are using it. So it is abbreviated as GRASS. GRASS is nothing but Geographic Resource Analysis Support System, and when you look at it, it is commonly referred as GRASS, just as GRASS. So it's when I say GRASS software, it's one of those effectively used GIS software for basically very effective in raster data processing. And when you are looking at Geographic Information System, it can look at anything under the sun that can be processed using a GIS software. Anything that can be modulated in terms of a GIS software can be done with GRASS. And when you are looking at whether spatial modeling, whether you are looking at the production of graphics, maps, or when you are looking at analysis, basically image analysis, so it is extremely useful software available today. So I would suggest if students to have a look at this particular website and probably even look at its functionality. You will be assured that you will not go back to any proprietary software for terms of using it with raster processing. Then you have geospatial data management, analysis, image processing, graphical maps, spatial modeling, visualization, then any complex analysis, and most importantly a support to Python. So you can use it as its code and modify it the way you need and present your research output. Okay, so and also most importantly is that the QGIS is well known, so it has a support with QGIS. From the QGIS you can call GRASS and use it as one of the raster processing tool inside from the QGIS itself. So it was developed in 1984 for the US Army as a land management support system and evolved as a general purpose GIS. In 1999, GPL international team of developers were handled this. It is actually portable. Any of the common OS can be used, whether it is 32 or a 64-bit. Only thing is that please see what kind of architecture your particular system supports, whether it is a 32-bit or a 64-bit, and use this particular software. Then normally most of it is coded in C. It is interoperability through GDAL. It extends interoperability to any softwares through GDAL. Okay, and more importantly, now in today's scenario, you need something that is a web-based infrastructure. So it supports SVN and online source code browser, which with bug reports, users and programmers manual, wiki, IRC, etc. So that you have both web-based infrastructure that is already there, community of users who is actually looking at it, the source code that is available, and most importantly any bug that is being reported is being addressed in a phasely manner, very fast. In fact, in terms of hours also, the turnaround time may be sometimes even less than 24 hours. So that's how GRASS has become extensively used in a very large community worldwide today. So this is what is the development model of GRASS. So we had GRASS, first thing is we had developers and users which who are using, they have an interface through internet through a bug tracker. There is an RT bug tracker where most of the bugs are reported, and this is actually handled by the patchers who actually look at these bugs and patch it up. Then you have CVS source codes available. Then you have mailing list. If you just join your mailing mailing list, you can see huge number of users who are actually replying to every aspect of research needs any researcher is working on. So if someone wants to is stuck at certain point of time, just address in this mailing need, I am sure that someone will reply to you with saying the solution that is really that may be available, or maybe in a direction towards that solution which you may have to work. So it is extremely good in terms of mailing list. And then you have GRAS releases, that is a documented sample data that is already available. You can download it while that when you are downloading the software or installing the software. So that's how the entire model is quite good in terms of development and usage. And when you look at GRAS as a software, you have you can develop it as I said, where you can import or export any kind of raster or vector formats. You can display all your raster and vector data, you can process an image, you can look at raster analysis, you can look at vector analysis, you can look at point data analysis. Then most importantly, you can, once you have developed all your data, you can even model it. So that's how the GRAS is extremely useful as a raster processing software. Okay. Now when you are looking at as a researcher or a planner, you can probably look at import export, you have a display, you have image processing, and as I said, it also can handle the database, that is through PostgreSQL database files more effectively than most of the proprietary softwares that are available today. So this is just to tell you the entire module of how GRAS.js is built. So you ask for any thing that you have to work, so most of the things are available with GRAS.js. So the next thing is the Quantum GIS. This you have seen. So it is a user friendly GIS. I would say it's a collection of tools or a software which primarily is an official project of OSGeo, that is Open Source Geospatial Foundation. It is under the GNU public license. So I have spoke about the license already. It is under the GNU public license, and when you look at QGIS, it is available with Linux, it is available with Windows, it is available with Unix, Mac OS X, and if others if any. So most of these users can use QGIS. So and when you look at QGIS as a feature, okay, softwares, there are certain features of a particular software, why you like that particular software. For the first feature, that the most important thing is cross platform. For example, maybe in your college you have a Windows platform, and at home you may be using a Linux platform. So whatever you have developed there can be easily cross platformed here. Okay, so it is not that you are stuck with only one and you have to do with that. So it is cross platform, you can install in any kind of platform that or an operating system that you can have. Most important is the free and open source, available free of cost, okay, not even licensing or a distributing cost, and most important is it's open source. That's helpful for most of the researchers around the world. Robust support to vector data. Vector data is its prime point. Handling vector data is the where QGIS excels. Okay, vector data model. So when you are probably you have seen how well it can handle most of the vector data in last 2 weeks of this particular course. Then you have raster data processing. This is with the help of GRAS. So as we spoke previously, GRAS is very effective in terms of handling raster data. So this combines GRAS with itself. So the raster data processing is also quite effective. Digitizing. So like you do in any other GIS software, proprietary GIS software, it can do 2D and 3D digitizing in much easier way, the same way that you do in most of the other software. Plug-in to other GIS related software. Yes, it has a lot of plugins. You can plug in with other GIS software related software, and also it has a repository of plugins which you can download and install, which you have already seen and can be used. So that's how it is very different from many of the other softwares. And GPS tools. So many proprietary software do not offer a support to GPS. in terms of when you have collected data and you have to put it on the right platform, it may not be possible. So GPS tool support is available in QGIS. Then you have OGC, that is Open Geospatial Consortium support, which again is extremely good, which is actually the basic part of any of these open source software. And if someone is looking at today's context, most of the thing is that you have to develop it on the web. Anyone who are looking at today's developments, it is through a web service, okay, whether it's a map or a feature. So you are looking at a web service. So here it supports map server, which can handle the data, both raster and vector data, very effectively, and you can utilize it as a web service, so that anyone who wants to use your data, visualize with your data, visualize with your code without having any kind of hardware or a software, can easily look at that just by logging into that particular URL with a web browser support. As simple as that, anyone with a mobile phone can get into that. So that is why today's context is developing in towards that. The decision support is happening towards developing, and more importantly the portable kind of decisions that can be made at every instant of time without having a large amount of hardware and software. So that is where we are moving towards, and yes, QGIS provides support for that also. Then you have OGR converter. So Open Geospatial Raster Converter, you can convert most of your formats. As I said, this interoperability can be there, and it is provided through GDAL. Then you have georeferencer. So you have used georeferencer, so I would not get into all of these details. Okay, the last kind of software that I would like to develop is FragStat. So just to tell you what is FragStat, it is a spatial pattern analysis program for categorical maps. For example, let us say I have developed a map of land use of a particular region. Let us say the region is Kharagpur. So now I want to understand, I have a map of 1990, I have a map of 2000, I have a map of 2010, and I have a map of 2019. Now I want to understand how Kharagpur has grown over a period of time. In 1990 it was probably only IIT Kharagpur and maybe some settlements just next to it. Now once in 2000 it may have grown over the entire railway block. Okay, in 2010 the railway, it is going beyond the railway block and maybe reaching the next location, and maybe in 2019 it has developed. So how it has developed, what kind of development has happened? Okay, whether it is developing in patches, whether it is developing in classes, whether it is developing as a landscape. Okay, what kind of development, whether you can call it as sprawl, whether you can call it as a cluster development. So such kind of analysis can be done for any urban context. So this can be done using FragStat. So it simply quantifies the aerial extent and spatial configuration of patches within the landscape, or landscape analysis in the landscape. So any kind of thing you can do. It does not limit the scale of a landscape subject to analysis. That is the best part of FragStat. So many of the software, for example, there is something called spatial analysis which actually limits the scale, which FragStat doesn't. Then you have landscape of extreme extent or resolution may result in rather cumbersome numbers to be subject to the rounding error. So please be careful. So if it is a very coarse resolution, you may not, none of these will be very effective in analyzing your data. If it is a medium resolution or very high resolution data, okay, very high spatial resolution data, then your most of these, whatever I am speaking about, the tool is extremely useful in urban planning. FragStat outputs normally in ASCII file format that can be manipulated using any database management program to rescale metrics to convert them to any of the other units. Okay, so I will just give you a brief about how FragStat works. For example, FragStats can be just type in the Google, you can download FragStat. FragStat is a very small program, maybe in terms of MBs you download it, and when you double click it, you get even the portable format, you get even the installable formats. I am using the version 3.3 which I love it the most. There are recent versions of 4 now it's 5. So all these versions are there, more modified versions, better versions with large number of metrics are available, but I am very comfortable with 3.3. so I am giving you an example of with FracStat 3.3. So this has a huge amount of metrics that you can use, and these metrics, see, these metrics are not only made for urban analysis, this can be then used for ecological analysis, it can be used for environment. Basically it was done for ecological analysis, now it is being used as an urban analytical tool also, it can be used for environmental analytical tool, it can be used for hydrological analytical, any kind of analysis that you want to do in terms of looking at patches, configuration, etc. on the landscape, that can be done with FracStat. So first thing is the file menu, which actually gives you how do you open, how do you create a new a particular instance in order to run the FracStat, then you have open, save, etc. The most important part here is to set run parameters. Okay, when I say run parameters, this is how it looks. Okay, it can take an ASCII file name, it can take an Idrisi file name. Okay, so when you are actually putting in the run parameters, you have to give an ASCII file or an Idrisi file. Okay, then you can even give an 8-bit binary here, or a 16-bit binary, or 32-bit binary. Then you have ERDAS format can be directly used, and Idrisi format can be directly used. So this is the input kind of data. Based on this data, this would change. Okay, now once you have given this, let's say you have hundreds of the same kind of data that you have to use. Okay, same analysis that has to be repeated over, maybe you are looking at concentric circles, maybe squares. So if you want to do it, you can always automate it with a batch file. Okay, create a batch file and automate it, which can be used as an instance here. Okay, if you use this button, radio button, then it will create a batch file, but otherwise you can use it as a input data only. Now then you have grid attributes. The cell size in meters is your resolution of your satellite data. Okay, if it's Landsat, so you may enter it as 30, otherwise you may enter whatever its spatial resolution is. Then you have background values, then you have number of rows and columns. If you look at metadata of your satellite image that is available, then it gives you number of rows and number of columns. So that has to be entered here. Then you have analysis type, one is a standard, another one is a moving window. So there are two ways of looking at it. Standard is normally used when you have running parameters, which is quite standard to the analysis of whatever you are trying to do. But moving window gives you a different kind of understanding that how you weigh each and every parameters across your research domain. So this also can be looked at in a different way. So probably if you want to look at it, please look at some of the literatures that are available. Then most importantly, you have to input here is a class property file. So when I say a class property file, so what basically it is a description of whatever the raster image that you are entering here as a input data, or a vector image that you are inputting as a input data. So what basically that is, for example, when I am inputting it as a land use data. So I may have created a land use with urban, vegetation, water, others, or urban, say then evergreen forest, deciduous forest, water, then others. So with this you have to put in the class properties files as what are the different classes that are available, how many classes are there, whether it is 4 class, 5 class, 6 class. Okay, and what is the name of that class. For example, the first one is urban, the second one is water, third one is vegetation, fourth one is others, and rest is nothing but null. So this has to be inputted as a class properties file in this particular tab, or you can even develop that particular file. Then you have patch neighbors, how the rule has to be, whether it is looking at the 4 cell neighbors, the 4 neighbors, or whether it is looking at the 8 cell neighbors. Then finally the output statistics, whether you want to look at patch. For example, if you are looking at urban analysis, let us take a city, not city of today, maybe let us say a tier 3 city which was actually developing. Now in the tier 3 city you may have a core area. Okay, there may be some towns away from the core area, 3-4 towns, even inside the municipality boundary there may be other classes also that has been developed. So, which means they are in patches. So, if you are looking at how many patches are there, how it is actually converting, how it is actually changing over a period of time. For example, if there is 100 patches at today, so you say that this is kind of a patchy growth, and higher the number of patches, it means to say that there is cluttered, there are many other classes that are there in a land use configuration. But if the number of patches starts decreasing and then becomes a single patch, it means entire landscape that you are analyzing has become a single urban patch. It means everything has converted to urban, right? So, that's one of the that's one of the kind of analysis that you can do. That's why you look at a patch matrix. But when you are comparing across a class, so you are looking at class matrix. If you are looking at overall understanding of a landscape that you are inputting, then you are looking at landscape metrics. So, these are different ways of of things that has to be inputted in terms of understanding over a fracstat. So, this is what what I have mentioned. So, you can look at it, all of these information, so when leisure. Okay. So, yeah, so I said about the standard analysis and the moving window analysis. If it is a standard mode, then the fracstat will produce a conventional outputs, that is for input landscape consisting of dot patch, dot class, dot land files. Okay. If it is a moving window analysis, it conducts a moving window analysis in terms of output as a new grid. It produces a new grid for each of the selected metrics. So, this is what I have spoke already. Not get into this. This is how it runs. It processes your the first file that you will be working with. Then this is where it has finished its run. Then the results are saved somewhere here as patch. I have selected as a patch matrix, so results are saved here, and you have adjacency file which gives more information about it. Then these are some of the metrics. I would not get into all of these details. So, whichever metrics you need, you can just select it off. Then you have land metrics, then you have class metrics. There you can select whichever the metrics that is appropriate for your analysis. Okay. So, let me give you one example. For example, this analysis done over Bangalore, the growth of Bangalore from 1973 to 2010, from a very small region, urban region, to the today an agglomeration. So, we can even call it as a metropolitan city with maybe in a few years. So, it has grown out of bounds today. What we did was we looked at the Bangalore as a city, then we divided it into 4 zones. Okay. And also we looked at in terms of concentric circle. Here when you look at it, we divided the Bangalore from as a 2 kilometer concentric circles from the center. You have C1 to C13. So, Bangalore with a 10 kilometer buffer was 26 kilometers from the center. If you measure the radius, it was 26 kilometers. So, when we divided it, you have 13 circles. So, every circle was input as input file. So, which means we created a batch file of 13 different raster files. So, with this we understood the patch metric. The one patch metrics that we have understood is number of urban patches, which means to say that how many urban patches were there in 1973, how many urban patches were there in 1992 in that particular circle, how many urban patches were there in 1999 in that particular circle, and how many urban patches were there in 2010. Now, when you see this, okay, and it is with directions. So, I have put the directions here. We have considered 8 directions. So, when you look at this, if let us say that I have taken a south-west-west direction, you can see here the urban patch in the core were very less, which means that instead of patch, it was completely a single patch and no other classes were there in the core. Whereas, when you looked at the outskirts, the patches were less, but when you as you go on, the patches increased. Here the urban area was less, but when you as you went on, the urban area increased and the patches also increased. When the patches have increased, you can see the core almost closing down to a single patch. Okay. Here in 2010, core has already in all directions have closed down to a single patch, which means the entire core area of Bangalore is completely urbanized, whereas the outskirts of the city is a cluttered format, which means it is sprawling away from the city. City ends somewhere in the 8th circle or the 9th circle, and then it has started sprawling, which means outskirts of the city. You can attribute it to various industrial growth. For example, 1992 we set up the 1990s we set up our industrial units. Then the educational institutions came up in various nook and corners of the state, of the city. Then in 2000 with the IT revolution, Bangalore became the Silicon Valley. So you had growth in those regions, for example the Koramangala region, the Whitefield region, etc. in 2000, 2005, 2006 onwards. So you can see those regions actually pulling up in a large way. Then now the consolidation has started back. If you look at 2019 published literature, the consolidation of all of this has started, and it now the threshold is being reached as far as urban growth is concerned. So on a summary, we looked at the different open source software. We started with OSM as an library, then we looked at GDAL, we looked at OGR, how effectively it can handle data. Then we looked at softwares, GRAS, QGIS operations, and most importantly we looked at FragStat, how it can be used for any research analysis. And finally I gave you an output of how FragStat can be used for different urban analysis. So with this I would end this class. In the next class we would learn more about different aspects of open source and its connected issues and the way it has been developed. Okay, till then have a nice time. Thank you very much.